Today my topic is on the subject of design of machine elements. Today we will discuss on design of piston. So now we will see that design of piston. So this in this design, this is a very most important component of piston. The piston is invented by German scientist. His name was Nicholas August Otto in the year of 1866. Piston generally it will compress that gases whatever coming out from the inlet manifold piston, and it is having a reciprocating it will be used reciprocating pumps, reciprocating engines, gas compressors, pneumatic compressors, among other similar mechanisms in which it helps to convert the chemical energy obtained by the combustion and fuel useful into that mechanical work and mechanical power. So this purpose of the piston is to provide by means of conveying that crankshaft via connecting rod. Generally, the piston is manufactured by aluminum alloy, cast iron, wrought iron, and other materials, aluminum alloys. So piston is eccentrically a cylindrical plug. It is called as a cylindrical plug, and it moves in the engine cylinder from up and down. So piston rings are to provide a good seal for the between the cylinder and the piston. So here major forces acting on the piston is first forces axial force, it will work on that, and due to explosion of fuel gases, whenever the fuel is going to be means that the pressure, once the pressure means that the fuel is burned inside of the cylinder, then the piston moves down. That at the time one force is acting, that force is called as expulsion of fuel gases, and second one is due to compression of fuel gases. Whenever burnt fuel will be there, then that is called as compression of fuel gases, and the other side is called as side wall friction. Means whenever a piston is moving from top to bottom, this walls, it is going to be touching that cylinder walls. That forces is called as frictional force, and forces, and one more force, side wall friction. These two forces will work on that piston. Another one more, fourth one is thermal loads. So thermal loads means heavy loads will carry that IC engine over there, that entire thermal loads will be there. What are the exhaust gases and what are the burnt gases will be there, that forces we are going to calling as thermal loads. Another one is called as inertia force. Inertia force due to high frequency of reciprocating of piston and friction and forces at the crank pinhole. Over there another one more friction will be there, very small force. That force is called as friction forces at crank pin shaft, crankshaft. Next we will see that these are the forces acting on that piston. Next, what is that functions of the piston? What is the main function of the piston? Piston is reciprocated in the engine cylinder, and gas tight will be there, and suction, compression, and exhaust strokes it will work. This main function of the piston is that to reciprocate inside of the engine cylinder. Another one is to receive that thrust load will be there. So thrust load means so much of load whenever gases is burned, that gases, that is called as thrust generated force, we can say that, and that is that one of the major it will withstand that thrust forces. It is also one of the function, and it is going to be connected to that piston pin to the connecting rod, small end bearing, and big end bearing is going to be connected to that uh, crankshaft. So one more function is that it will guide that bearings and small end bearings of the connecting rod and take the side thrust of the due to obliquity of the rod, connecting rod. These are the main functions of the connecting rod. And this in this function, this and some more factors we will consider for proper functioning of the piston. The piston should have enormous strength should be there, and it will be heat resistance. So like that properties withstand gas pressure and inertia forces. They should have minimum weight to minimize that inertia forces. The material of the piston should have good and quick dissipation of heat from the crown to the rings bearing area to the cylinder walls. Okay, another one more factors to be considered is material of the piston. It will possess that good wearing qualities, and that piston is able to maintain sufficient surface hardness unto that operating temperatures. Another one more function to consider when we are going for the design, piston should have rigid construction to withstand thermal and mechanical distortion and sufficient area to prevent undue wear. It has to be explanation under thermal load should have free possible from discontinuity. This is also one of the most important. Now we will see that how that piston will be there. You see that piston, how that different parts will be there. In the side, three rings are we are going to keeping over there. One is compression ring, another two or three are oil rings. Why that compression should not be leakage wherever compression will be there inside of the engine cylinder. Another two rings will be provided for the lubricating purpose. Lubricating purpose. See that, and design properties will be there. I am showing that these are the design properties of the piston. See that piston crown will be there, piston head will be there, top land will be there, down land will be there, and piston pin and center pin will be there. All these things ribs will be there, piston ribs will be there. So I am showing a skeleton diagram of the piston. So in this piston, it should have adequate strength will be there, and to withstand the forces due to pressure of the inside of the engine cylinder. And one more important for piston is considerations. These are the two main considerations to design the piston. So the second one is it dissipates the heat, means whenever combustion is going on inside of the engine cylinder, the heat will be displaced. Valves quickly as possible on the basis of the first consideration, straining action. So the thickness of the piston head is determined by treating as a flat circular plate we are going to considering, and we are going to designing the piston. Next we will see that what are the remaining considerations. Means piston rings we are going to using for the necessary radial pressure. We are going to maintaining that radial pressure and seal between the piston and the cylinder bore. So this already we discussed that piston and cylinder bore. So these are usually made of grey cast iron and alloy cast irons and aluminium alloys. The piston rings of following two types. One is the compression rings, another one is pressure rings. Oil rings are oil scraper. The compression rings are pressure rings. Compression rings we are going to calling as pressure rings. Oil rings are oil scraper, means whatever oil will be there, we are going to scrapping in the engine cylinder walls at the top portion of the piston, and maybe 3 to 7 in number. These rings are also transfer heat from the piston to that cylinder liner to absorb some part of the piston fluctuations. Okay, these are all that considerations and regarding about piston rings and compression rings. And piston script will be there. This piston script I already shown on the figure. Piston script will be there. In that piston script, the portion of the piston below the ring section is known as a piston skirt. What is that definition of the means? What is that? We have to know that what is a piston skirt. The portion of the piston below the ring section is known as a piston skirt. It acts as a bearing for the side thrust of the connecting rod. The length of the piston skirt should be such that the bearing pressure on the piston barrel due to the side thrust does not exceed, we cannot exceed 25 Newton per mm square of the projected area for the low speed of the engines and 0.5 Newton per mm square for high speed of the engines. These are the design consideration when we are going for design. So it may be noted that the thrust during the expansion stroke and the side thrust we are going to denoting by capital R, and usually we are going to take in as cylinder liner is usually 1/10th of the maximum gas load on the piston. Maximum gas load on the piston. So maximum gas load on the piston. So now piston pin. Now we can we have to see that one more part of in the piston pin. The piston pin we are going to also we are going to calling as gudgeon pin. So the gudgeon pin will connect that piston and the connecting rod. Connecting rod means small end bearing. We are going to connecting that piston and connecting rod. Generally, it is made of hollow and tapered sections. Generally, it is passes through the bosses provided on the inside of the piston skirt. So here the center of the piston pin should be 0.02 D to 0.04 D. Generally, we have to consider piston pin should be that much of diameter. Above the center of the skirt, and in order to set that turning effect and friction effect and uniform distribution load should be there in the on that piston pin and small end of the connecting rod. This is a very most important. This piston pin, it will be play that major role to transfer that energy from crankshaft to that piston. So generally the material we are going to using for that case hardened steel generally, and containing nickel, chromium, molybdenum and vanadium. Generally the material we are going to using to manufacture that piston pin is hardened steel containing nickel, chromium, molybdenum, vanadium, all these things. So it can be withstand maximum 710 megapascal to 910 megapascal. 710 megapascal to 910 megapascal. And design consideration of the piston. A piston for IC engine, the following points should be taken into that considerations. So what is that? First point, what is that design criteria whenever we are going to seeing that? What is that? So first one we are going to seeing that it should have enormous strength should be there, and it should have withstand that gas pressure and inertia forces, and the effective gas and sealing of the cylinder. That is a main design consideration. Another one more important one is the piston should have speed reciprocating without noise. Whenever this piston is operating inside of the engine cylinder, there should not be any noise. It should have high speed reciprocation without noise. Why? Because the piston is going to be acting inside of the engine cylinder. So it should not. If that noise is coming out, so much of disturbance will come into that whenever operation is going on in that IC engine. And sufficient rigid construction to withstand the thermal and mechanical distortions. So it should have that to withstand that thermal and mechanical distortions. Another one more thing, it should have sufficient support for the piston pin. It should have sufficient support to be there. Okay. Another one is design of for piston requirement. Okay. Design of this piston requirements means the piston should move to the reciprocating motion to the inside of the cylinder. Another one is reducing the friction between the connecting rod and piston. Another one is there is no strain occurring the piston pin. Piston move even though at the minimum pressure also it can be moved. So that this is that piston pin considerations. And now we will see that what is the structural design. We will see that piston should be designed in a cylindrical shape because usually move up and down in direction. Piston should be compact size, means very limiting size, where that how much it should be there. In that limiting size only we have to design the piston geometry, curve or flat or any other shape. That's a geometry, very most important, piston geometry, and should correct the shapes and maximum efficiency. Material for pistons, the most commonly used materials for piston of IC engines, generally we discussed cast iron will be there, aluminum will be there, forged aluminum will be there, cast steel will be there, and forged steel will be there, and all these things we are going to using for the piston. Okay, so in this criteria, we have to, whenever we are going to designing such a piston, the structural design should be there. Another one more important, the expansion of aluminum should be there 2.5 times of the cast iron. These are all the things we have to remember whenever we are going for manufacturing of the piston. And but it clearance should be allowed. The piston will be developed, piston slab should be there. It is called of tendency to increase the wear. Whenever the piston structural design is not proper, so structural design should be there. Okay, structural design will be there. And whenever to prevent that sizing of the piston, the engine runs continuously under heavy loads. So allowed, piston will develop a piston slab and the tendency increases the wear. So sizing of the piston, since that aluminum alloy we are going to using, piston should have high thermal conductivity and a high strength, and it should keep as maximum temperature, different temperature, and where we have to keep this temperature center and edges of the piston. This is a very, we have to note this point for whenever we are going to design a piston. So that since that aluminum alloy and about this 3 times lighter than that piston. So now we will see that the temperature should be there at above 325 degrees. Sometimes piston aluminum coated as aluminum oxide, and electrical method will be there. Electrical method also we are going to manufacturing this at low temperatures, but they lose that strength about 50%. Means whatever temperature will be there, minimum the temperature should we have to maintain that 325 degrees centigrade. Next video we will see that remaining part of the design of piston.